Hello everyone, hope you are doing good today. So in this video we are going to discuss AWS Certified Solution Architect Associate exam, okay? And also I will provide you the practice exam set, okay? That is the set number 1. So in my next video I am going to provide you the set 2, okay? So before starting practice exam set 1, so let's discuss something regarding AWS Certified Solution Architect exam, okay? So what is this exam actually? AWS Certified Solution Architect Associate showcases knowledge and skills in AWS technology across a wide range of AWS services. The focus of this certification is on the design of cost and performance optimized solution, demonstrating a strong understanding of the AWS well architect framework. So why you need this certification? I think nowadays most of the companies are migrating their services to AWS cloud, so they need many developers with knowledge on AWS. So this certification can enhance your career profile, and also it will increase your credibility and confidence in stakeholders and customer interaction. So how you can prepare for the exam, okay? So first you need to buy some video tutorials like from Udemy. So like this is the Udemy site. So if you log into Udemy, you can buy this course, okay? So this is the course with the latest AWS services. And then there is like AWS cheat sheets, okay? So here AWS provides few documentations for the certification exams. So if you go for AWS Solution Architect Associate, so you can click here and then you can go and study all the services, okay? Here it's like all the key point has defined in this link, okay? So I will provide the link in the description of the video, so you can go through it. And after finishing video tutorials and AWS cheat sheets, okay, you have to practice few exam sets, okay? Otherwise it will be difficult to pass the exam, okay? And few tips to find the correct answer, okay? So you have to find the keywords, and also you have to think of the architecture, and then you have to select the serverless design always, okay? Because AWS will prefer the answer with serverless architecture, okay? So now let's go to the practice exam set, okay? So this is the set 1. I will provide the set 2 in my next video, okay? So let's say question number 1, okay? So it's saying an electrical company has developed a new application which has been successfully deployed on AWS for an upcoming sale, okay? Okay, so before going to the question answer, let me activate the pen, okay? Upcoming sale of the company is expecting a huge rise, okay? So you have to mark it, okay, in the traffic. And while testing for the event, they have encountered performance issue in the application when many requests are sent to the applications. And now they will say you regarding the applications, okay? The current application stack is Amazon Aurora Postgres database with an AWS Lambda compute layer fronted by API gateway, okay? A solution architect must recommend improvements, scalability, minimizing the configuration effort, okay? So which solution will meet this requirement? So here you have the keywords, okay, and then you have to design the architecture, okay? So if you design the architecture, however, it's saying that API gateway, okay? So let's say you have API gateway here, okay, and then you have Lambda, okay? let's say lambda, okay. Then it's saying you have database, okay. So you have a postgres.database, okay. Let's say this is the database, okay. So you also have the keyword and also have the design, okay. Now API will connect to the lambda, okay. So now there are many traffic, okay. So the lambda is not able to perform the many requests. So few requests will have lambda cold start time, okay, and then the request will process very slowly, okay. So how you can improve the performance? So what it's saying, the architecture, okay. So this is the architecture. Now let's go through the options, okay. So here also it's saying that minimizing the configuration effort, okay. Change the platform from Aurora to DynamoDB. So it's not possible because we have already written the SQL queries, okay. So this is not the good choice. So now set up two lambda functions, configure one function to receive the information and configure the other function to load the information into the DB, okay. Integrate the lambda function by using Amazon Simple Notification Service, okay. So like they are saying to create another lambda here, okay, and then lambda will connect to DB and you have to create a SNS here, okay. So you have to create a SNS here, okay. So SNS is not for decoupling the system. So SNS is only for fan out the messages. So this is also not the correct answer, okay. So now let's go to the C, okay. Set up two lambda function, configure one function to receive the information and configure the other function to load the information into the database. Integrate the lambda function by using a simple queue service, okay. So SQS. So this is the perfect solution, okay. So API will post the message to the first lambda and then lambda will post to the SQS queue, so that lambda no need to wait for the inserting the data into database, okay. So that lambda can respond to the user faster, okay. So in this way you can improve the performance. So this is the perfect answer, okay. And refactor the lambda code into Apache Tomcat. So this is not the serverless architecture at all. So we can remove this from the options. So the C is the correct answer, okay. So question number 2, okay. So I am giving you a few time to read the question. So it's saying a medical company uses several Windows server. So here the keyword is Windows Server as the operating system of choice for their application servers hosting in their data center. The company wants to move some files server into the cloud and keep some in their data center mounted to the same file system. The company also wants to maintain extremely low latency across their on-premises data center across a private network. The company has an AWS direct connection set up into the US East 1 region, okay. What should a solution architect do to meet the requirement? Okay, so here you need to think of the keywords, okay. Windows Server. So Windows Server file systems, they need to move it to the cloud, okay. So the SMB client supports only, and also Windows Server supports only FSX file system, okay. So if you read the first option, install an SMB client into the on-premises server and mount an Amazon FSX file system into the server, mount the same file system on EC2 instance within the Amazon VPC, use the existing direct connect to connect the on-premises. So this option should be correct for me, I think, because Windows Server only support this file system, FSX file system, okay. And the option B, NFS client and the EFS, you see this is for Linux, and DynamoDB is not for any file system, okay. And S3 is not also the correct option. Now let's go to question number 3. A computer game developed company is planning to build a cloud-based game platform on AWS. The player activity patterns are unpredictable, so this is a keyword, and cloud remain idle for extended periods. Only players who have purchased the game should have the ability to log in and play. Okay, that means there should be a authentication mechanism. Which combination of steps will meet this requirement most cost effectively? Okay, so here unpredictable, that means the traffic is not predictable, and also user can remain idle, that means user after login user can sit idle, and user may not do any activity. That means it's asking for serverless architecture. Okay, that means in serverless, if you don't use it, you don't have to pay for it. Okay, so let's go through the options. Use AWS Cognito user pool to handle user authentication. Yes, this might be one of the option. Implement an AWS Lambda function to fetch player information from Amazon DynamoDB. Establish an Amazon API gateway endpoint to handle the REST API calls. Direct them to Lambda function. I think yeah, this is also the right option because it's serverless design. And leverage AWS Amplify to serve the front-end game interface with HTML, CSS, JSS. Use the integrated Amazon CloudFront configuration. I think this one would be the better option also. So let's go to the next option. Use AWS Cognito Identity Pool to handle user authentication. I think Cognito Identity is not for user authentication. It's for user rights management. So this is not a correct answer. Set up an Amazon container service ECS service behind an application load balancer to fetch player information. So this is not a good serverless design. Okay, so now you can deploy the application either using AWS Amplify or Amazon S3. So here it's saying use Amazon S3 static web hosting with HTML, CSS, JS. Use Amazon CloudFront to distribute the front-end game interface. But here with the S3, you have to design your own authentication mechanism. Okay, like the login page and all. But AWS Amplify will provide you many features to develop an interactive application. So for me, AWS Amplify will be the best option here. So now let's go to the next question. So the question is, a big logistics company collects shipment tracking information which updates every few seconds. The company wishes to perform real-time analysis on this data updates to monitor shipment progress and predict delays, after which they want the data to be ingested into their Amazon S3 based data lake. Which solutions will fulfill these requirements with the most operational efficiency? Okay, so here the keywords are real time. Okay, so they are receiving some updates data on their shipments, and they want to process them real time to predict some delays. Okay, so now let's go to the options. Use Amazon SQS for data ingestion and Amazon EMR for real time analysis. So SQS is not for real time analysis, it's for decoupling the systems. So now go to the B. Use Amazon Kinesis data stream for data ingestion and AWS Lambda for real time data analysis. So here we know that Kinesis data stream is for real time data processing, but the AWS Lambda is not for real time data processing. So I think these options will not be correct also. Use AWS Direct Connect for data ingestion and Amazon Athena for real time analysis. So Amazon Athena is not for real time analysis, it's for querying some S3 data. So this is not the correct answer also. Use Amazon Kinesis Data Firehose for data ingestion and Amazon Data Kinesis for data analytics for real time analytics. Yeah, so this option is the correct, because you know that data firehose can point to the many different endpoint. One of them is Amazon Kinesis data analytics, so you can use this, and after data analysis you can push it to the S3. So this should be the correct option. Now let's go to the question number 5. An Indian services company has a large multi-region footprint on AWS. A recent security audit highlighted some issue that must be addressed. The company must track all configuration changes affecting AWS resources and have detailed record of who has accessed the AWS environment. The data should include information such as the user has logged in and which API calls they have made. Okay, so here which API calls they have made and configuration changes. Okay, so we know that you can manage the configuration changes using AWS config. Okay, and you can track the API calls using CloudTrail. Okay, so you have to remember these two options. Okay, so now let's go to the options. Use AWS config to track the configuration changes. So this is correct. And Amazon Event Bridge to record. So Amazon Event Bridge is not to record the API calls. So this is not the correct answer. Use Amazon Messi to track configuration changes. So this is not correct at all, because Amazon Messi is used to find some data in S3. So this is not the correct answer also. Use AWS config to track configuration changes and AWS CloudTrail to record API calls and track access pattern in AWS Cloud. I think this would be the correct answer. So AWS config for configuration changes and CloudTrail to record API calls. Use Amazon CloudWatch to track configuration changes and AWS config. So this is not correct at all. Now the question number 6. An education firm is aiming to leverage AWS Cloud, augmenting its on-premises disaster recovery architecture. The firm main application running on PostgreSQL is housed on a virtual machine, that is VM, on premises. The DR solution needs to align with the application's recovery point objective RPO of less than a minute and recovery time with of 2 hours, all while keeping cost to a minimum. Which solution will meet these requirements? So here they are talking about some disaster recovery. Okay, that means you have deployed your application in one region, let's say that is US East 1. Okay, now US East 1 goes down. Okay, so how can you make your application up and running in another region, that is, let's say, US East 2, in less than 1 minute? Okay, so to answer this type of disaster recovery questions, you have to remember this disaster recovery architecture design. Okay, I mean, if you go through this link, okay, I will provide this link in the description of the video. Okay, disaster recovery options in the cloud. So here we have 4 options. Okay, backup and restore, pilot light, warm standby, and multi-site. Okay, so backup and restores means you have your application in one region, that is US East 1, so you will back up all the application, then you will restore all these application in another regions. Okay, and then you will make it up and running. Okay, so it will take like hours. And then you have pilot light. Okay, pilot light, that means you already created the another region. Okay, and all the data are live and also the services are idle. Okay, services are not not up and running. Okay, that means the services cannot accept the request immediately. Okay, so that's called pilot light. Okay, and another one is warm standby. Okay, in warm standby, that means your environment is ready and always one part of the services are already running. Okay, you just need to scale it up when the event is occurred. Okay, that means you can make your environment up and running within minutes. Okay, like less than 1 minute. And the another one is a multi-site active. That means you have two application up and running. One is already serving the production traffic and another one is deployed in another region. Okay, that means you already set up your 2 environment. If one region goes down, you can point the traffic to the another region. Okay, that is like real time. So that you can do here. So now let's go to the slides. Okay, so it's saying that here you have to find the keyword also, let me activate the pen again. So here it's saying RPO of less than a minute. Okay, so in the AWS documentation we saw that the warm standby takes less than 1 minute. Okay, so the option should be warm standby, so that is the first option. Okay, and we don't need to go through all other options, because whenever it will talk about some time like less than a minute, 2 hours, okay, so you have to go through warm standby, pilot light, or active. So for this it should be warm standby. Now question number 7. A large quantity of data is stored on a NAS device on premises and accessed using SMB protocol. The company require a managed service for hosting the file system and a tool to automate the migration. Which action should a solution architect take? Solution architect take. So here the keyword is SMB protocol. Okay, SMB, that means it should be a Windows file system. Okay, that means it's a Windows server. So we have to find the file that is supported by Windows. Okay, that is should be FSX for Windows file server. Okay, and it should be like there is a tool to automate the migration. Okay, so it should be like AWS data sync or something. So migrate the data to Amazon FSX for Windows file server using AWS data sync. So I think the first option is the correct. And FSX for Luster is not for, I think, Windows, so it should be for Linux. And migrate the data to Amazon S3 using AWS Snowball. So here Snowball is not required at all, because we have to automate the migration. So there should be a connection between the on-premises and the cloud. EFS is not supported by Windows, because here it's the SMB protocol, so this is not the correct answer at all. So the first option is the correct one. Now let's go to the question number 8. A company runs an API on a Linux server in their on-premises data center. The company are planning to migrate the API to AWS cloud. The company require a high available, scalable, and cost-effective solution. What should a solution architect recommend? Migrate the API to API gateway and migrate the backend to Amazon EC2. So this may be the valid one. So let's go through the other options. Migrate the API server to Amazon EC2 instances and auto scaling group and attach an application load balancer. The next option is migrate the API to Amazon CloudFront. You cannot migrate API to CloudFront, so this is not the good one. Migrate the API to Amazon API gateway and use AWS Lambda as the backend. Okay, now let's compare option A and option D. Okay, so option E, that backend to EC2, so this is not a serverless design. Okay, but here it is a fully serverless design. Okay, so the option D should be the correct one. Okay, and this is also not correct. So you have to choose here the serverless design, that is API gateway and AWS Lambda. Now question number 9. Online, it should be an online. Okay, an online store is running an important event. The company require guaranteed capacity in 2 specific availability zones in a specific AWS region for running Amazon EC2 instances for 5 consecutive days. So here you have to, the keyword is specific availability zones. The company require guaranteed capacity and for 5 hours, 5 consecutive days only. Okay, not more than that. What is the best way to ensure guaranteed EC2 capacity? Okay, so now let's go to the options. So option number 1, purchase reserved instances. So reserved instances is not provide you the required capacity. Okay, and also reserved instances is not good for only 5 consecutive days, so this is a not good options. Create an on-demand capacity reservation that specifies the region and 2 availability zones needed. I think this should be the correct one. Let's go to the next one. Create an on-demand capacity reservation that specifies the region. So here availability zone is not mentioned, so this is not the correct one. Reserved instances, so this is not the best fit for this scenario, so the correct option should be B, that on-demand capacity reservation that specifies the region and two availability zones. Okay, so it will reduce the cost. Now go to the next question. A news company is running a production workload on thousands of EC2 instances which run a custom solution provided by third-party softwares. This software is subjected to regular updates and patches by the third-party organizations. How can a solution architect patch all the instances quickly to remediate a security exposure? So here the solution is that you have thousands of EC2 instances and you need to install a patch on those EC2 instances. Okay, so how you can do it? So for this you have to study the AWS cheat sheet. Okay, so let me show you. If you go to this cheat sheet, AWS system manager, okay, here you will see all the things: incident manager, patch manager, okay, and then run command. Okay, so all the theory is here. Okay, so you can read it a bit. Now let's go to the slide. So here it's saying the patch. Okay, so now let's go to the options. Schedule AWS system manager maintenance window. So the maintenance window will not be the correct one because there is no downtime. Configure AWS system manager patch manager to apply the patch to all EC2 instances. Here it's also mentioned quickly, okay, to remediate. So the correct option is, I think, the B, because the patch manager can do the job very quickly. You can do the same thing using run command, but I think the run command is not for specific to running patches very quickly. Create an AWS lambda function to apply the patch to all EC2 instances. So this is possible also. You can write some code in Python or Java, okay, and then you can apply the patch in all the EC2 instances. But why should we use it when AWS provide the out-of-the-box solution using AWS System Manager? So we don't need this one also. So this one is not correct also. Now let's go to the question number 11. An online retail store is building an e-commerce application on AWS. The application sends information about new order to a REST API hosted on Amazon API Gateway to process. The company needs to order the order to be processed in the order that they are received. Which solution will meet the requirement? That means you have to maintain the order, okay? If your system is receiving all the requests in a order, so you have to process those in that way. That means here it's talking about fast in fast out, okay. Whoever will come to the system first will be processed first, okay. So now let's go to the option. When an order is received, use an API gateway integration to send the message to Amazon simple queue, FIFO queue for processing. Configure the SQS FIFO queue to invoke the AWS Lambda. So FIFO is fast in fast out, so I think this is the correct option. So these are not the correct option. Simple notification, these are not correct option. SQS, here it's saying standard queue will not maintain the order, okay. So this is not the correct option also. So here in question number 11, whenever you will see to maintain the order, okay, the answer should be with the SQS and the FIFO, okay. Now let's go to the question number 12. A global financial service company is currently operating a 3-tier web application to handle their main customer facing website. The application uses several Amazon EC2 instances behind an application load balancer and connect directly to a DynamoDB table. Due to recent customer complaints of slow loading times, their solution architect has been asked to implement changes to solve this problem without re-architecting the core application components. Which combinations of actions should the solution architect take to accomplish this? Okay, you have to select two. So here it's saying a 3-tier web application to handle the main customer facing website application use EC2 instances behind the application load balancer. Okay, so here you have to think of the architecture. Okay, so let's draw the architecture design. Okay, so let's say this is the website. Okay, now it's saying that you have a load balancer. Okay, let's say this is the load balancer. So here you are sending many requests. Okay, now you have many EC2s. Okay, so let's say these are EC2 instances. Okay, so all these are EC2, so you have many EC2 instances. Now this will route the traffic to the EC2 instances. Okay, and now you have DynamoDB. Okay, DynamoDB. Okay, so now let's go to the option. Set up Amazon DynamoDB accelerator cluster in front of the DynamoDB table, that is the DEX. This is called like the caching management. Okay, DynamoDB caching, so it will process the request very faster. Okay, so I think this will be the better option also, because it's saying the slow loading time. Okay, because a customer is complaining about slow loading, so it will so EC2 will now connect to the DEX. Okay, it will also now the application can process the insert operation to the DynamoDB very faster. Okay, and also the read operation using DEX. DEX. Okay, so you have DEX here, so this is the correct option, I think. Migrate the entire application to Beanstalk, because here it's saying without re-architecting. Okay, so this will not be good options. Create a CloudFront distribution and place it in front of the application load balancer. So here it's saying to put a CloudFront. Okay, CF CloudFront. Okay, so CloudFront is to store all the static content. Okay, so to improve the performance, so that user can have the response very faster. So this is one of the options. Migrate the DynamoDB to Amazon Aurora. So this is not possible, because here it's saying re-architecting. That means you cannot make the code changes. So here you have written some queries to retrieve the data from DynamoDB, so you cannot make it Aurora. Okay. Migrate the web application to hosted on a container solution using AWS Fargate. So this is also not required, because here it's saying you cannot change the architecture. So for me, option A and option C is the best answers. So now let's go to the question number 13. A music streaming company needs to incorporate a third-party song feed. The song feed sends a webhook to notify an external service when new songs are ready for consumptions. A developer has written an AWS Lambda function to retrieve songs when the company receives a webhook callback. The developer must expose the Lambda function for the third party to invoke. Which solution will meet this requirement with the least operational complexity? Okay, so here you have to think of the architecture. Okay, so architecture is saying, let's say there is a song feed. Okay, so let's say here is the song feed. Okay, and then there is a external application. Okay, so external application, and now you have AWS region. Okay, this is, let's say this is AWS region. Inside AWS you have a lambda function. Okay, let's say you have the lambda function. Now it's saying the developer must expose the lambda function for the third party to invoke. Okay, that means the external application third party here. So which solution will meet the requirement with the least operational complexity? Create an Amazon simple queue service, connect the queue to the lambda function, provide the ARN of the SQS to the third party of the webhook. I think third party cannot invoke SQS directly. Okay, so this is not the good option. Create an API gateway endpoint for the lambda function, provide the API gateway endpoint to the third party for the webhook. So here you can create a API gateway. Okay, so API gateway, this is API gateway. So and then you can provide it to the third party system, that means external application, and then API gateway can invoke the lambda. Okay, so here whenever the external application will receive the webhook, it will automatically trigger the lambda function using the API gateway. So for me the option B should be the right one. Deploy a network load balancer, distribute the request to the lambda function, provide the NLB URL. This is also possible, but this is not required. I mean NLB is not required, it will be more expensive. Create a simple notification service. So simple notification service is not required here because it's to fan out the messages. So here it is not required at all, and you cannot call a notification service directly from an external application. So for me the better option is B. Now question number 14. A company has an on-premises server that uses a MySQL database to process and store customer information. The company wants to migrate to an AWS database service to achieve higher availability and to improve application performance. Additionally, the company wants to upload reporting workload from its primary database to ensure it remains performant. Which solution will meet these requirements in the most operationally efficient way? So now we have to find the keywords. So a company has an on-premises server that uses MySQL database. Okay, now they want to migrate to an AWS database. Okay, so we have to find the equivalent of MySQL database which is supported by AWS, and also you have to maintain the higher availability. That means you have to install the database in multiple availability zone. Okay, and also you should have a read replica. Okay, so that you can point the read operation to the read replica only. So now let's go to the options. Use Amazon RDS with the MySQL with a single availability zone deployment. So this is not true because you need higher availability. So now let's go to the second option. Use Amazon Aurora with MySQL compatibility. Direct the reporting function to one of the Aurora replicas. I think this is the best for this scenario, because Amazon Aurora is the serverless database for MySQL compatibility. Okay, so and also Aurora has support for multi availability zone deployment, and also it has like a 15 read replica activated. Okay, and you can direct the reporting function to the read replicas. So this is the best options with serverless design. Okay, now the second option is use AWS database migrate to create Aurora DB cluster in multiple AWS region, point toward the DB instance in primary. So this is not true. You cannot do the disaster recovery. I mean it's saying higher availability, so here it's not saying disaster recovery, so multi-region is not required. Now the option D, use EC2 instances to deploy self-managed MySQL database. So here it's not a good option because we always prefer the serverless design. So MySQL compatibility is the best options with the Aurora database. Now question number 15. So this is the last question of the set 1. And retail website uses Amazon EC2 instance to store for Amazon EC2 instance store for storing session data. The company want to make sure that this data is highly available and that the information is stored durably. What should a solution architect do to meet this requirement? Okay, so now they have session data in EC2 instance store. The company want to make sure that the data is highly available and information is durable. That means EC2 instance store, that means this is a store of the EC2 server. Okay, and if the EC2 instance is shut down, then you will lose the data. Okay, because this is not a permanent storage. So here it's saying that we have to store the data durably. Okay, that means we have to keep it some durable storage services. We have to keep it in some durable storage services. So now let's go to the options. Move the session data to S3, Glacier Deep Archive. So I think S3 is not good for session data, so this is not correct. Move the session data to Imagine Elastic Cache, Memcached. So this is a better options for session data, but here it's saying we have to keep it durably. So this is not the good for that option, I think. Deploy a large EC2 instance with a large instance store. So this is not required at all, because we have to keep the data permanently. Store the session data in Amazon DynamoDB table. I think this is the correct options, because DynamoDB table you can keep the session data and data can be stored there permanently using a TTL, like for more than 1 year you can keep the session data. So this should be the right option for me. So that's all for today's video. So this is the set 1 for AWS Solution Architect Associate exam. So in my next video I will provide you the set 2. So if you like the set 1, then please like this video and also subscribe to my channel for more videos related to AWS. Thank you guys, thanks for watching.